Hi everybody. So this is the second video in my series on adding and subtracting with volumes of revolution. So in this question, we're told that the diagram shows the region bounded by the curves with equations y equals 8 minus x squared and y equals 2x, and the line x equals 0. The region is rotated through 360 degrees about the y-axis. Find the exact value of a solid generated. So as we revolve this shaded region around the y-axis, we create a solid, which looks something like this. And what we're going to do is we're going to find the volume of this solid. Now, because it's being revolved around the y-axis, we're going to use the equation where the volume is equal to pi multiplied by the integral between the range of a to b of x squared dy. So I covered in a previous video where this equation comes from. So there's two parts in this solid. There's the top part shaded in red and the bottom part shaded in blue. And we're going to use integration to find both volumes. To use integration, we need to find this point of intersection, which is here. We'll call this point P. So at P, these two equations are equal. So we can say 8 minus x squared will equal 2x. And we can solve this quadratic by moving the negative x squared and the positive 8 to the right-hand side. So therefore, we get 0 will equal x squared plus the 2x minus 8. And we can solve this by factorizing. So we'll have x minus 2 multiplied by x plus 4 give us 0. X will equal 2 and negative 4. And you can see we're only interested in this positive 2 solution, which is here. And if x equals 2, then we can substitute this 2 into here, and we'll get y equals 4. So we'll say at point P, we have the coordinates 2 and 4. Now this y value of 4 forms our limits for both solids. So we'll include this in our diagram. We'll mark this off on the y-axis. So now if we begin by finding the volume of this cone, this will be pi multiplied by the integral between 0 to 4 of x squared. But what we've been given is the equation in terms of y. So if we divide both sides by 2, we get y over 2 is equal to x. So x squared will be y squared over 4. So we'll put this into our integral. So y squared over 4 integrated with respect to y. And we can move this quarter out in front of our integral. So this becomes pi over 4 multiplied by the integral between 0 to 4 of y squared dy. And we can evaluate this integral as pi over 4 times 1/3 of y cubed between 0 to 4. And now we can move this division of 3 out in front as well. So we get pi over 12 y cubed with the limits of 4 and 0. We can substitute in our limits. So we get pi over 12 times the 4 cubed, which is 64. When we substitute in 0, we get 0. So this will be lots of 64. We can simplify that as 64 pi over 12. So this is the volume of this blue cone. Now we need to work out the volume of the red solid on top. And again, we need to make x squared the subject of this equation. So we'll move a negative x squared to the left-hand side and the y to the right-hand side. So we'll get x squared will equal 8 minus y. Substituting this into the equation, this will be pi multiplied by the integral between 4. And we know this point of y will be 8, because when x equals 0, y will be 8, of 8 minus y dy. We can evaluate this integral as pi. Then we have 8y minus 1/2 y squared with the limits of 4 and 8. And then we'll substitute in each of these limits. So we've got pi, 8 lots of 8 is 64. And then we've got 8 squared is 64 divided by 2, so 32. So 64 minus the 32 gives us 32. Substituting in the 4, 8 times 4 is 32. This is 16, half of that is 8. So a 32 minus the 8 will give us 24. So the red solid will have a volume of 8 pi. Now to work out the total volume, we'll add together the blue volume and the red volume. So we get a total of 40 pi over 3 units cubed. Okay?